talking about energy efficiency opportunities in the Australian mining sector. Thank you, Amy.
Thanks. Thanks, Kelsey, for that. Thanks for that introduction, Kelsey. My name is Amy Joyce. I'm currently a fourth-year environmental engineering student at Murdoch University, and I'm undertaking an internship, which is part of my degree, and that's with Rio Tinto. So this evening I'd like to present to you energy efficiency opportunities within the Australian mining sector. And this is something that I've researched throughout my internship and also during my time at university. So just to give you a brief outline of what are we talking about today, I'll give a brief overview of energies in the mining sector, introduce the Energy Efficiency Opportunities Act, which has been brought in by the government, and I'll also be looking at a case study, and we'll be looking specifically at haul trucks. I'll get into this a little bit later on, why I've selected haul trucks for this presentation. So chances are, if you own a TV, have access to the internet, maybe even pick up a newspaper from time to time, you'll have seen that energy and climate change has been a hot topic. This is due in part to the 2013 federal election. There's been a lot of dialogue within the energy and greenhouse gas space. And basically what this does is place large energy users under the spotlight. Companies that use a lot of energy are in a position now where there's a lot of reputational risk associated with demonstrating poor performance. But in contrast, there's also a lot of good publicity available from demonstrating best practice. So this is a graph that you might have seen in the media. There's been a few talking about energy intensity and also emissions intensity. And basically what the attitude has been is that energy intensity and emissions intensity have overall been trending downwards due to more efficient practices within industry and also within domestic energy consumption. If we're looking at energy intensity, what we're talking about here is the amount of energy it takes to produce a given unit of something. So if you're looking at the energy intensity or the energy efficiency of a light bulb, for example, it would be the amount of energy it takes to produce a given unit of light. In the context of the mining industry, it's the amount of energy it takes to produce a unit of ore or a ton of ore shipped. So coming back to this graph here, while we've been told that energy intensity is overall trending downwards, you can see here that the mining industry is actually steeply trending upwards. So in the past couple of decades, this has been trending upwards at a rate of about 2.5%, and it's currently set to increase by a rate of 6%. This is due to a number of factors. For instance, the grade of ore has halved in the past 30 years, and what this has meant is a lot more energy is involved in processing the ore. So while the grade of ore has halved in the last 30 years, the energy use to extract a given quantity of ore has actually increased by 70%. This is due to having to dig deeper to find the ore, and also we're starting to mine below the water table, which means there's a lot of dewatering involved to actually extract that ore. It also requires a lot more processing at the plant to bring it to a standard that's able to be exported. So what did the government do about this? Well, in 2006, they brought in what we call the Energy Efficiency Opportunities Act. And basically what this act requires is that large energy users, those that trigger a participation threshold of 0.5 petajoules, are legally obliged to identify and assess opportunities to save energy within their business. I won't get into too much of the nitty-gritty of the act. There's a lot to it. If you have any particular passions for policy, feel free to ask me in the question time. But this is one of the main drivers for the mining industry in looking at opportunities to save energy. This brings me to my case study of haul trucks. I've selected haul trucks out of a great variety of mining processes and systems because they're one of the largest users of energy on site. You can see here, this is where they fit into the system, and they can use up to about 15% for total mine site energy. Haul trucks essentially carry ore to the fixed plant for processing, or they carry waste material to waste dumps. So that's their role in the process. Now, there's a lot of different ways that the efficiency of haul trucks can be maximised. These come down to basically design, fleet management, and also looking at setting standards and benchmarking performance. So the efficiency of haul trucks depends on a variety of factors. Things like rolling resistance, design of the haul trucks, design of the road, grade of the road. There's so many factors that come into it. So purchasing larger haul trucks is just one way to maximise efficiency. Now, I mentioned before that efficiency is the amount of energy it takes to produce a certain quantity. So by purchasing and installing larger haul trucks within the fleet, basically what you're doing is getting more bang for your buck. You're having to do less routes, less haul routes to transport more ore for basically the same amount of energy. Now this seems a little bit counterintuitive. You tend to think bigger trucks are going to use a lot more energy. Well, these bigger trucks are replacing older technology. This is not the case at all. In some cases, it's been shown that these trucks can actually be up to 7% more efficient than older fleet. So basically, by purchasing larger haul trucks, you're being able to transport more for less. And a study here by Jellinbar Resources, which is a mining company operating with an operation in central Queensland, found that simply by purchasing larger haul trucks, they could make a saving of almost $120,000 per year. And I'm going to talk mainly in terms of a dollar value when talking about energy savings, just because it's a little bit easier to put into context in your mind. If I talk in gigajoules, I think, well, how does that fit into the bigger picture? Another way to maximise efficiency is by looking at payload. Payload is essentially the amount of material that's being transported by the haul truck. By increasing the payload, basically what you're doing is filling the truck as much as possible to get as much bang for your buck, which is what I mentioned earlier. A lot of companies operate with a payload of about 80 or 90% of their total maximum capacity, so they're having to do more trips to transport the ore and using more fuel in the process. So these found that by increasing their payload, they were able to save about $2.5 million, which was substantial just by increasing the standards and procedures that they had set for that. Another way to increase the payload is by installing lightweight trays. And basically lightweight trays are just high quality steel trays. They enable more space, they have high capacity for less weight, which has implications on fuel performance. You can see here in this nice little graph, I'm not sure if you can see the bottom here, but by installing the lightweight tray, you're able to increase the payload by about 25%. So essentially you can relate this and say that's 25% less travel that you're going to have to do to transport the same amount of ore. And finally, in terms of payload management, you can look at reducing the carryback. Now what carryback is it's wet ore that remains in the back of the tray after dumping. And as we're starting to mine below the water table, ore is getting wetter and it's getting stickier. So what's remaining in the back of the haul truck when it's being dumped is actually compounding. And that reduces the total room available in the haul truck for material to be transported. So what we looked at doing was fitting an exhaust system that actually pumps the exhaust into the back of the tray, heats the tray, and this reduces the moisture content of the carryback, and this is able to exit the tray when dumping, and this just makes more room in the tray. So Rio Tinto found that this saves enough energy to run one truck continuously for 9 months. Benchmarking performance. This is basically a management tool, and what this does is has a look at different scenarios on a case-by-case basis and the implications on the fuel use. So this is an entirely theoretical tool that management can use in making their decisions. You can see here, this is by Leighton Contractors. They looked at optimising the payload, and you can see here the implications on fuel. So they've used this to implement into their decision-making process, minimising their consumption. Here's another metric that Leighton put forward. It shows here that trucks are a lot more efficient in dry conditions than in wet conditions. This is because the rolling resistance of the tyres is minimised. Don't have too much time to go into depth with this, but if you've got any questions about that. And finally, by minimising the times that a haul truck has to come to a stop and subsequently accelerate again, you can save a lot of energy. So what does this mean? Well, by implementing the strategies that I've just discussed, it's possible to achieve an 11% energy reduction across the entire mining fleet. This is subsequent, significant rather. You're looking at savings of millions of dollars for mine sites. And just to finish up, it's important to say that energy efficiency makes sense for businesses. If businesses were to carry on as usual, you can see here energy usage is just going to increase. By implementing energy efficient practices, we can minimise our energy consumption, minimise our greenhouse gas emissions, and save money. So just to leave you with a little something to think about. And I'll ask if you have any questions.
Have any of these practices been implemented in WA or worldwide or anything like that?
Yep. So Leighton's metric is being used all over Australia, nationally. Also, a few of Rio Tinto's reducing their carryback at the Mesa Jade operations, I believe, has been implemented with great success. A lot of them, it's important to say, they do make business sense by implementing these opportunities. So it's very rare that a company will scope them out, see all of these savings, and then decide not to implement them.
Have you factored in the cost, energy cost, and other costs of actually transporting these massive trucks to mine?
That's not factored into the calculations for the energy efficiency program. I guess it falls within more the supplier's scope rather than the purchaser's scope. So, for example, I'm currently doing my internship with Rio Tinto. They wouldn't factor into their energy usage the cost of purchasing a particular contracted item, if that makes sense. It would mainly be what they're actually using on site in their operations. So it's not actually something that's taken into account, especially not under the energy efficiency opportunities legislation.
You mentioned rolling resistance in several situations. What sort of studies are going on in that area?
There's a lot of studies about road grade and rolling resistance, different types of road materials in terms of mine planning and how that can influence rather the rolling resistance. Also in the slide I showed earlier about wet and dry road conditions, there's a lot of studies that are going into seeing what effect exactly driving in wet roads has on rolling resistance. Obviously the tyre will have to displace the water, but there's also a vacuum effect that's caused by, as the tyre is moving and the air is trying to fill around the tread, it's creating a vacuum effect which is creating a lot of resistance. So there's some work at the moment going into finding out how to quantify that resistance and see what can be done in terms of optimising tyre tread on the fleets. So there's some really interesting work in that field.
What is the general attitude of mining companies towards implementing these energy efficiency opportunities? You mentioned the energy efficiency opportunities legislation, but it's actually not compulsory to implement what you identify. You don't have to identify the opportunity, but you don't have to implement any of it.
You're exactly right. comes back to it makes business sense. If you're looking at some of these opportunities like I've shown you, that the savings can go to $2.5 million. If a company can look at that and say, there's not a lot of risk involved in implementing it, the savings are great, they've already spent the resources in assessing it and having a look into it, as long as the capital is there, which is a challenge at the moment, given the economy, a lot of companies are very keen to jump on board with these opportunities that I've found.
I said that at the moment they only fill the trucks to 80 something or 5% capacity. Why is that? Is that a system in place because of the risks of, for example, metal fatigue, always good capacity, the problem with the constant load on springs, and if you are to increase that to higher than the current, is that going to have associated problems? I'm assuming that those standards were put in place for a reason, those numbers were decided on for a reason.
Yeah. In the mining industry, I'm sure a lot of maybe the electrical engineers will be able to sympathise. There's a huge capacity for being extra safe. For example, a power station, you'll have multiple engineers working on it, and they'll add a 10% contingency, and that compounds and compounds and compounds. So what's happening in effect is you're being very, very cautious, and it's highly inefficient. The reasons for this, it's maybe someone's decided somewhere along the track that sounds like a good number. Let's not go any higher than that just in case. So part of the work of the energy team is actually to look at this and say, well, why is this strategy in place? Is there an actual scientific basis behind it? And how can we make it more efficient? Which is sort of what we're in the process of doing, and what these benchmarking tools are really helpful to do. But that is a very good question.
I'm going to have to, stop at that very good question. I hope you guys will continue discussing over networking. It's been 5 minutes. Thank you again.
Thank you.